All right, welcome to video 3 of practical exercise number 9 in chapter 5 of the Advanced GIS textbook. In this video, where we've been looking at green space and parks in the city of Springville, Utah, as expressed by normalized difference vegetation index and surface temperature from Landsat data, we're going to talk about creating models using Model Builder, i.e. creating your own tools, customized tools or processes in GIS, so that we can do things such as maybe export in mass files from a geodatabase, or we could run some sort of repeatable workflow and share that workflow with others. And in this particular video, we're going to focus on exporting raster data from a geodatabase. And the reason that we would want to do this is that file geodatabases or geodatabases in general are great for ESRI in terms of maintaining topology, keeping packages and other kind of functionalities that is available in ESRI products in terms of publishing online. But unfortunately, they don't play nicely with other software packages such as QGIS all the time, especially for rasters. And there are reasons that you might want to work in another program. Well, one thing would be that QGIS is free, and so you might be working with colleagues that don't have access to ESRI products, in which case you might need to share data with them. Another reason is that there's sometimes custom tools that have been built for these open source GIS softwares, which do things that maybe you don't have access to in the ESRI suite. One of them is the profile tool in QGIS is quite useful for tracking how different raster variables co-vary along a profile. And while we do have a really nice profile tool in the exploratory 3D analyst functionality of ArcGIS Pro, doesn't do all the same things that QGIS does. So so we will in this video create a model where we can export rasters from a geodatabase. And we will then open those up in QGIS, and I'll show you that profile tool. Okay, so we have created a lot of rasters in our geodatabase, or I have in this video tutorial, and I've done a bit of practicing, and so I've probably got even more rasters than you saw me produce in here. And so, you can always export things from a geodatabase by right-clicking and export one at a time to a different format, to a different location. But that's pretty cumbersome. And so this is one of the reasons we want to set up a model, something that we're going to repeat over and over again. To create Model Builder, we go under an analysis, and then look at Model Builder here. Opens up a new model within your Arc toolbox for your project. So you can see I've already got a couple in here that I was practicing on. And so we'll just try it. So what we're going to do is we're going to iterate through all of these rasters in the folder. And so that's under iterators, we choose iterate raster, and that brings this up. And then what we're going to do with them is we're going to copy them to a new folder. So just have to bring that in. So copy raster. Okay. And so this is pretty simple. So we're going to go through all the files in the folder that are rasters, and we're going to copy them to a new folder. We could do other things in this process. We could clip them to the same extent. We could transform them to a different coordinate system. And so you could put multiple steps in here and really make your workflow smooth and efficient. You wouldn't have to click as many buttons if you were to do this sort of thing over and over again. And so we can save these tools, and which I've done here, and they are available in this toolbox, which you can access, generally, even if you're working on another project. And so if you've got a nice tool that you want to use and you know you'll use regularly, you should not just call it model 1. You should give it a nice name describing what it does. So like I gave this one the name export rasters from geodatabase. And then you could access it again. To do that, you do save as and save once you've got it all set up. You can, in doing this, in this case, we're doing iterate through a geodatabase, and that's fine. That's a good way to set it up. Also, you can have like input variables. Like I could say that the variable that I'm going to input is like a raster file, raster data set. And so then I would set that here and I would join it to the copy raster. And then it's like every time I would be selecting the raster that I want to run through this tool. This is not very useful if you only got one thing that you're doing. That's not really any different than just running the tool from the toolbox. But if you've got a big, long workflow that you're working through, then that would be a useful thing. But in this case, we're iterating. So we just iterate through the whole folder. And so what we have to do is select the folder in the workspace. Whenever we use the tool, you'll have to change that. So the workspace is our geodatabase. And inside of here, there is something called a wildcard. And that means basically you can kind of specify which rasters you want to operate on by name, basically. So if you have them named in a certain way, like I have a lot of them that are named July at the start or NDVI. So if you know that you only wanted to operate on the NDVI files, you could type NDVI star, and it would only operate on those rasters that start with that name. If you leave it without anything in there, it'll do every raster in the folder or geodatabase. Okay, so and then what we see is it's iterate. It shows the first one it's going to operate on, and kind of the variable of name as it goes through there. And so then we have to connect it to this copy raster. And so what you want to do is go down to model variables, July 28th. It's this file, the first one that it's looking at, but it'll go through all of them. And we have to specify the folder where we're going to work. In this case, we're going outside of the geodatabase, so you have to have a folder set up. And I've got one in my Chapter 5 example called raster export. And then I have to give it a name. And since we're iterating through, you should use this %name caller, which basically it'll give whatever the input name was. And then you can add something to it afterwards. In this case, I'm not doing anything other than copying it. So I'll add the file extension TIFF. And so it knows it's going to be a TIFF format. We don't really have to add anything else in here. It'll just keep the same values that it had on the input. Okay, so here's our raster export folder. There's nothing in it right now if I click on it. And so hopefully this works. I've had a couple times where I've run this and it didn't work. And I troubleshot it for like half an hour. And what made it work is just saving, restarting the program, opening it up, and running the model again. So don't bang your head against the wall. A lot of times, ArcGIS Pro just needs to be restarted to get things to work, or sometimes even just pressing run again will make it work. Okay, so right now I'm working on model 1 for an example. Like I said, we could have saved this as and given it a nice name, copy, raster, new folder. Okay, so there, now I'm working on that one. I click run, and it should just go and go and go. And this will run for quite a while because it's building pyramids, computing statistics for each one of those rasters. And like I said, there's more than 20 something of them. You want to be careful, of course, if you're copying really huge files. Oh, I ran into an issue where it failed. Let's refresh and see how many I got. I got the first 3. I got all the ones that started with July 28th, interestingly. Let's see, is that true? Yeah. So, well, let's see. Yeah, so direct, it did only the ones with that first starting name. Um, and I'm I'm gonna try something else. So we could do this in piecemeal, like, and you might want to do this, right? Because what I was getting cut off and saying is that basically when you are exporting out of a geodatabase with many, many rasters, some of them could be really big, like LiDAR data sets over a gigabyte each. And so maybe you only want to do certain ones. So right now we've got temperature in for the 2025 data. If I go back in here and look at what we've got, so that's fine. Let's also get the NDVI. So let's do those star NDVI star for recursive. Okay, and then save, and then let's see if it'll run on those. And so maybe I'll just do recursive for all the ones that we want. So this will give me my NDVIs. Of course, I probably should have just done this for the NDVI models that were clipped to Springville. Okay, so it completed without any errors. If I refresh that folder, now I can see that I've got all the NDVI files. And now if I look through, what else do I want? I guess I want the surface temperature from 2010. So I need to do those ones. I could also do the temperature deviation files. Let's just do the surface temperatures for now. So if I go back here and now I do, those are called SIR at the beginning. SIR T. Whoops, SIR T with a big T. Okay. And save, run. Then I'll have NDVI 2010, 2025, and they're also the ones that are clipped, and we'll have temperature data from the 2 time periods, but not clipped. That's okay. Okay, so you can see this saves us a bit of time, right? From right-clicking, exporting each individual one, renaming them, etc. So this is good. Hopefully you see the value in that. Especially like if we were going to do a series of operations, like we were going to iterate, we were going to reproject them, we were going to clip them, then we're going to copy them and put them in a new folder. We just set that up once. We click the button to which folder we're working on. Maybe we add in kind of that wildcard, and then just click run. You can operate on like 10 files with 1 click or 2 clicks. So that's the value of Model Builder. So now these are in this folder that's accessible to QGIS. Okay, so now we can bring them into QGIS. So let me just show you that and why we want to do this. So if I go into Dropbox, where I have this project that I'm working on, teaching course development, just move this over. So we are in 3650, the book, chapter 5. If we go into green space Utah, we can see the geodatabase, but if I click down to look into it here, it's having a hard time to do that. It should at least show us what's in there. And yeah, so we can see some of the clip out raster. These are got some zonal statistics tables. So like here's one, surface T, the surface temperature 2010 Fahrenheit clip. So let's see if we can add that in here. I'm pretty sure it's tricky, but maybe it'll work. It doesn't look like anything, does it? Okay, so now you're seeing what's going on. It just can't read things quite right out of here. Let's try it with something else. Let's remove these. Remove layer, there we go. And maybe you find a way to do this, or maybe it'll get better with time, but the proprietary ESRI geodatabases just don't play nice with everything. So NDVI, let's add that in. Into layer, there's just nothing there. I double click on it, nothing there. So yeah, it just doesn't work. So now we'll go and show you how the value, right, of what we just did. So we instead go back to the chapter 5 example, and we've got this raster export folder where we get all these things. And now they show up with these kind of pixel looking chessboards. And those are accessible and should load in here fine. And so we'll bring in surface temperature clip. See what that looks like. So this is Springville surface temperatures. We'll bring in, so that's 2010. We'll bring in, do we have 2028? Yes, we do. In Fahrenheit, this I don't think is clipped. That's okay. So that should be a bigger area. Zoom to layer. Doesn't seem to be showing up fully. Why is that? All right, we'll hold off on that. Let's bring in NDVI for Springville 2025. Okay. NDVI 2010 Springville. And we'll bring in, let's try to get the July temperature again. So let me remove this one. I don't know why it wouldn't be down there. Yeah, that degree C is everywhere. Let's try again. I think it was a display problem. Okay, so degrees Fahrenheit, pull that in. Doesn't quite go down there. Okay, so we will work on degrees Celsius in that one, and I can show you just some functionalities in here. Okay, so now we've got degrees Celsius for 2028. Move this up above that. There we go. Let's move them kind of in order. Okay, so and then we can display things differently in here too if we want. And so, working in another GIS program is all about getting used to how to deal with things. So symbology, single band, pseudo color. So now I'm looking at NDVI. So if I press apply to that, we get different color scheme. Okay, let's zoom in and see how that looks. Go back to properties. And so it shows us the range of values over how it's stretched. It's stretched negative as being red, going to orange, to yellow, to green, and to blue. Now that's a suitable way to go, right, for thinking about activity and health of vegetation. Could probably choose a different ramp. We could just go with all greens if we wanted. You have choices, just like you do in ArcGIS Pro, though their choices aren't necessarily the same. This one looks pretty good. Let's apply that. Yeah, so we can see the streets are showing up as brown and the nice green lawns and grasses as green. So I like that. Okay, so that's sitting over temperature. And so that could be displayed differently. And so single band, pseudo color, temperature could, oh, and you can customize it. Sorry about that. Let's go spectral, but can we flip that? Not sure how to do that. Invert color plan. Right click on it. There we go. Okay, apply. So hot is red. Okay. Oh, and that is under here. There's that. Okay, and we could do the same thing for these other ones. So go to single band pseudo color. It remembered which one we were using. We have to invert it again. Oh, I was looking at the units are different, right? So that's why it doesn't go as high, but in terms of visualization, it should be fine, right? So there's temperature across the region. And then the only one that we haven't worked on is the NDVI 2010. So we go to properties and we can find another single band that we can work with. And no, I didn't like that for this one. Okay, there we go. Okay, so now I've got NDVI on top, and the one that's showing right now is 2010. I can put 2025 on top of that. Okay, I've got different color schemes, so bear that in mind. Similar, but different, right? Partially that's different ranges that are in there. Okay, so yeah, so you've seen how we can kind of bring these rasters into QGIS. We can change their symbology, and there's a lot more that we can do with that, just like we can in ArcGIS Pro. I have added this profile tool, which is just called terrain profile. It does more than terrain, so that's a bit of a misnomer. The way I did that was manage and install plugins, and then it connects you to many different available plugins, and you can search through there and install them. Okay. And so these are plugins that people or entities have developed, and it's very customized, and use kind of this open source wonder. This is the tool right here, and it pulls up. There's nothing there, but at first, but we can draw a profile line through the city. I guess I'll go kind of east-west. So going across different regions of vegetation. Okay, there's nothing on there yet because I haven't added a layer. If I add a layer, it adds whatever was selected. So it added NDVI values for 2010, and it added them in the color red. I could change that to say green. Okay, and then what it shows across the profile, everything is above 1 in here. It shows, as you go along the profile, right, you can see areas that are high, like this field, and areas that are low, like this barren lot. And so not a lot of vegetation there. So that's a pretty nice feature. You can scroll along and see where you are on the profile. Now it gets better if we add another layer. Whoops. Move that. Got two of the same. Okay, so now I click on the other NDVI and I add the layer. And now I've got 2025 and 2010, and we can see how they co-vary, right? So that big field that was there in the 2010 data is not so green in 2025, but some areas are similar. And so you can see how things have changed directly on that pixel line. And then we can see how this relates to temperature. So I could turn off one of these, and now I'm just looking at 2025. And so then maybe I add in 2025 temperature. Now the issue here is scale. So it's on a different scale. So I think there's a way to add a second axis. Let's see. Same axis scale. You can customize these axes. Well, let me change so temperature will have as blue. If I do same axis scale, that just makes it even more kind of hard to read. So that's not helpful. Oh, well, you can change them into like a percentile. Or no, it's the slope of it, isn't it? Okay, so that's the derivative of the value. Okay, so we'll go back to that. So it's a little challenging when we have huge differences like this of scale. And so uh, if we had a second axis to plot on here, that wouldn't be the case. We could always do that somewhere else. Another way to go would be to basically, so you could kind of scale your NDVI up to a realm that was similar to your temperature, especially if you're working in Fahrenheit and you just multiplied by 100 on your NDVI. I think that would be reasonable relatively to look at. Another way to go would be to do a temperature deviation from the average, and then we'll be much closer to zero. We'll be orbiting around zero like NDVI does with temperature deviation, but we'd have like a range of like 10 to 20 above and below zero. So we could see more directly how things relate. Go back to settings. Well, another thing we can do, right, is to make this scale really big. So we can see that as we go to kind of high values, of NDVI. Maybe we're at lower values of temperature. And that's what we'd expect. And that's the value of plotting them together. Yeah. So yeah, you can plot multiple things on one axis. That's the real benefit here. And so we could also bring in surface temperature from the other year. And the problem here now is that one is in Fahrenheit and one is Celsius. So we need to do a conversion to make that happen. But how they co-vary along the same line is pretty cool to be able to have that all there. If you could then export this, you've got everything in one kind of graph, and it's quite nice. Okay, so that's a little bit about using QGIS and exporting rasters from a geodatabase to make them accessible for another program. Okay, so I'll end this video here. The next video will be looking at zonal statistics to understand how surface temperature and NDVI relate across parks in Springville.